Welcome to our GCSE required practical demonstration. In today's demo, we are going to be looking at the use of quadrats and line transects as random sampling methods in determining a population of organisms, as well as comparing organisms in a field. Here is our quadrat. It's normally a 1 square meter frame. Sometimes it could be any dimension they choose, so note what is a dimension in the exam. Now, in this case, we are choosing a 1 square meter frame. As I said, it's a random sampling method, and so we're going to throw this randomly. I'm going to throw it over my shoulder a number of times. In this case, I've chosen to do it 7 times. So here we go. We have a number of daisies that have been covered by the, bordered by the quadrat, and I can count how many. So in this case, 1, 2, 3, 4, 5, 6 daisies. So I record this as my first result. I'm going to repeat this until I have 7 results, okay? So again, you would go over, count how many daisies you have and record them. So you're carefully looking at the grid, just the daisies bounded by the grid, and you record how many there are on your table. We are going to then calculate the mean given by the total number of organisms, that's daisies, divided by the number of quadrats, as I said, 7. I did this and I got 154 daisies within the 7th rows of the quadrat, so that gives me 22 daisies per quadrat. Now if one quadrat gives 22 daisies and it's 1 square meter, then we're thinking that if the whole area is actually 30 meters by 20 meters, then we have an area of 600 square meters. Now, for the 600 square meters, we would have an estimate of 22 times 600, 13,200 daisies in the entire field. Okay, so this gives us an idea of how many daisies we have here without having to go and count every one of them. Now, we may also use a line transect. So in this case, I have my line transect here. It has gradations on it, so I can see various numbers on it to tell me how far it is from the base of that tree. This method enables me to count how many daisies are actually in touch with my line transect at 1 meter intervals and to record it. So I have a table to record my results. I have distance, perhaps from the base of the tree, if that is my reference point. Then number of organisms, in this case daisies. I would repeat this whole investigation 3 times. So trial 1, trial 2, trial 3, and calculate the mean. So at 1 meter, I'm going to go how many organisms are in touch with my line transect. So here I have from 13 to 12. Yep, how many daisies? So I can record 0 daisies here. Okay, I then go 2 meters away. That's from 12 to 11 here. 2 meters away, how many daisies are in contact with my line transect? And that's another 0. I keep repeating this until I get to the distance that I require on my table. Now, as I said, this whole process needs to be repeated 3 times. Now, I would move this transect perhaps to the left. stretch it out. All right, so I'd repeat this whole process to one side of where I took it and then repeat it to the other side. So again, I would begin to count the number of daisies in contact with my line transect and record it on the table, right? So at 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, how many daisies are actually in contact with my line transect. After doing this over 3 trials, I'm now ready to calculate the mean or the average. This is done by adding the number of organisms over the 3 trials for each distance and dividing by 3. So I'm going to obtain a result here, result for 2 meters, 3 meters, and so on. I can meaningfully construct or plot a graph that shows the average number of organisms on the y-axis and the distance, which is my independent variable, on the x-axis. So I hope this has helped to explain the use of quadrats and line transects. All the best in your exams. Bye.